Hello, pre-calculus student. This video is for chapter 5.1, part 2. We are looking at another way to measure angles instead of using degree, which is from 0 degree to 360 for a revolution. We would use another method called radian. The reason why we use it is because we want to eventually use angle as an input to a trig function, and angle from 0 to 360 is associated with degree. So we want to use a number that has no units. So this another way of measuring degree is called radian. Radian actually is a measure of central angle of a circle that intercepts an arc equal to the length to the radius of that central angle. Namely, instead of looking at an angle as like just like this, right? We imagine that there is a circle of radius r, and then this terminal side intercept this angle, and with an arc length, this arc length is s. We call it s. And then we imagine how many radius length is this angle. Okay, so this is S is not a length, is equal to the number of radius. Oh, X is arc length, but the radian, okay, so S is arc length. Right? If this angle sits in the center of the circle, and the angle become the central angle, we call it a central angle. Then the arc length that we have, the radian, tells us the degree of how much the two rays spread out is S over R. It tells us how much arc length this is relative to R. So technically speaking, if you have the radius of R, 1R would be here, right? So this would tell us an angle. So this particular angle would be angle is equal to 1, but not 1 degree, 1 radian, because it is associated with an arc length of exactly R size. And then 2 would be when it is the whole angle go this, theta equal to 2. That means this is 1 R length, this is another R. So it's basically tells you, now 1 and 2 are the ratio of the arc length with R, so it has no unit. Okay, and we know, so what about the whole circle? How many radian do we have? The radian of the circumference of the circle is 2 pi r. So the whole circle is circumference over r is 2 pi. So the whole circle is 360 degree is associated with 2 pi. And 2 pi in value is 6.28. That means if you are measuring the whole circle, you would have 6.28, 6.28 times of radius length. And we will have this summary. One revolution or one rotation or revolution is 360 degree, is called 2 pi radian. Half revolution, which is kind of like that, is 180 degree, is called pi radian. So this is pi radian. And then 1/4 of a revolution is 90 degree, is pi over 2 radian. So these are the way you measure angles. So we would not be using degree as much before, now that we know radian. So remember, I think this is the most important one. Half of a revolution is pi radian, is 180 degree. Okay, to convert from, I don't know why this is like on the left side. Let me see if I can move it back. Oh, it's not very good. So I should just cut it. Okay, I'll do it later. So if I have a degree, I want to convert into radian, you multiply pi over 180. And if you want to convert from radian to degree, you multiply 180 over pi. And if that is the case, let's do some conversion here. So we know earlier that 180 degree is pi, right? So this would be pi. This is 0. So pi, if you don't have a degree, that is the same as radian. Okay. What about 150? Let's do this 3 first. We know 90 degree is pi over 2, because this is pi, this is half of it. And then this is kind of like 3 pi at half pi, so it's 3 pi over 2. So we don't say 1.5 pi. We use improper fraction of 3 pi over 2. And then what about 30 degrees? So if I want to convert into radian, I would say I divide by pi over 180. 30 divided by 180 is 6. That's equal to pi over 6. So 30 degrees is pi over 6. What about 45? 45 is half of 90. So what is half of pi over 2 is pi over 4. And what about 60? So we'll convert one more time like that. If we convert it to radian, that's we multiply pi over 180 is pi over 3. Because we divide by 60, 60 is pi over 3. The others are similar. So, but the way we think about it would be 150. Instead of thinking of 150 times pi over 180, that's very long. We can think of it as pi minus pi over 6. Because it's pi minus 30 degrees, which is pi over 6. Just so always remember this. And then 1 pi minus pi over 6 is 6 pi over 6 minus pi over 6. That is equal to 5 pi over 6, right? So this would be 5 pi over 6. Likewise, when I think of 135 degree, I will think of pi minus pi over 4. That is 4 pi over 4 minus 1 pi over 4. That's 3 pi over 4. And when I think of 120, I think of pi minus 60 degree. So if I do pi minus pi over 3, because 60 degrees pi over 3, that would be 2 pi over 3. So think of using fraction subtraction and fraction addition to do this. 210 is pi at pi over 6, right? Pi plus pi over 6, that is 7 pi over 6. Pi plus pi over 4, it will be 5 pi over 4. And pi, this one would be pi plus pi over 3, would be 3 pi over 3 plus pi over 3 is 4 pi over 3. What about this side? So 330, we know 360 is 2 pi, right? So 2 pi. You can think of it as 2 pi minus pi over 6. So that is 12 pi over 6 minus pi over 6, 11 pi over 6. So special angles, you don't need to do the conversions. You do the conversion for the basic one, and then you do pi add or subtract or 2 pi subtract. So this would be 2 pi subtract pi over 4, right? So that would be 8 pi over 4 minus pi over 4. That's 7 pi over 4. And this is 2 pi minus pi over 3. So that is 6 pi over 3 minus pi over 3 equal to 5 pi over 3. So I would have this 5 pi over 3. So there we have all the radian measure of special angle in a circle. So this is special angle because we can actually find the exact value of some trig function. So this is important. Okay, now example 2 would be converting this each of these back into degree and also convert some non-special angle degree into radian. Okay, pi over 6. I'm converting radian to degree. I times 180 degree over pi, right? So times 180 over pi. Pi and pi cancel. 180 divided by 6 is 30 degree. 3 times 180 over pi would be, well, I just multiply across. So this is the degree, right? So will be 180 times 3 over pi degree, right? So put in the calculator. Do I have one? Yes. 180 times 3 over pi. Pi is this one, second up arrow. This is the pi. 171.9 degree. Well, it's almost 180 degrees. So what about negative 3 pi over 4? It's negative 3 pi over 4 times 180 over pi. Well, the pi cancel. Divided by 4 is 45. Divided by 4 is 45. So it's negative 135 degree. 45 times 3. Right. So convert to radian would be times pi over 180. So they are always multiplying this. Pi over 180. If I divide 180 by 15, 180 divided by 15, 15, that is 12. So that means this is 1 and this is 12. That's pi over 12. So keep the pi there for exact value. This would equal to 126 times pi over 180. Can I simplify 126 over 180? So I can do 126 divided by 180 and then see what happened. Oh, it's 0.7. So change it into fraction. 7 over 10. So it'll be 7 pi over 10. Okay, keep the pi. Negative 75 times pi over 180. 75 divided by 180. Again, math fraction. 5 pi over 12. 5 pi over 12. Oh, it's a negative. Example 3, sketch. Now that we know what radian is about, we can sketch things in standard position. So let's remember our pi over 2, pi, 3 pi over 2. 3 pi over 2 means 1.5 pi. This is 0.5 pi, right? This is 1 pi. This is 2 pi. So if I want to do 3 over 4 pi, that's 0.75 would be in quadrant 2, right? Is 0.75 pi is greater than 0.5 pi. So it must be in quadrant 2. So we put it here and then draw the arrow. It's positive, right? 3 pi over 4, like that. What about negative 4 pi over 3? So that is negative 1.3 pi. This is 1 pi. This is 1.5. Oh, but I'm doing negative, so it'll be like this. This is, oh, okay. So for negative, I would say negative pi over 2. This is negative pi. So I would, negative 1.3 would be over here, right? Negative 1.3. So I would draw it this way by saying negative 1 pi, but 1.3 is in quadrant 2. This is also in quadrant 2 because the terminal side is in quadrant 2 and the turn is negative like that. So you just need to know if it's more than 1 pi, more than 0.5 pi, or more than negative 1.5 pi. So this negative is positive. Okay, so in the next video, we'll talk about coterminal angle.